So today I want to talk about how AI and large language models are affecting programming, the act of coding. I'm a bit less interested in all the conversational kind of applications that have taken everybody's fancy and more in how it's changing how we program. So, I already got a great introduction, so I won't go over all this stuff. I'll just mention that, yes, I work at Google, but this talk is in a purely private capacity. Those are the links to some of my websites and socials. I cover some stuff similar to what I'm going to be talking about on my YouTube channel over here. So as I was trying to come up with the material for this talk, I was wondering how to frame it. And it's not so much really about programming with AI. As I was thinking more about it, it really is about programming with new and unfamiliar tools. So as programmers, we obviously have a very kind of in-depth relationship with our tools. We're almost defined by our tools. And I think we're at a place where that entire toolbox is changing. So I want to start with a little bit of history to situate us in the time we are right now. Let's look at where the term software engineering came from. Back in 1968, NATO had a meeting of people that were doing computer stuff. The term software engineering came out of that conference. This was the who's who of computer scientists at the time. I don't think computer science as a discipline was even named at the time. So it was people from IBM, people like Dijkstra, the people from AT&T Labs who made Unix. And one of the big themes of that NATO conference was the thought that software is not industrialized enough. The construction of software is not like the construction of other industrial goods. It's not predictable, it's not modular. And Doug McElroy, who some of you might know as the person who created pipes, one of the coolest things about Unix, is trying to make this idea that we need software to be more like industry. We need it to be more like how we manufacture goods, with standard parts, with modularity, with predictability. So keep that thought in your mind. This is a really interesting paper all the way back from, I think it was in the 1980s, from the International Conference on Software Engineering. And it's got many kind of lasting paper impact awards since. Leon Osterweil proposed this idea of software processes themselves being software. And this is a very beautifully meta idea. The idea is that the act or the process of writing software itself can be modeled as software. And a lot of what he wrote 30 years ago now has come to pass, because if you look at things like CI/CD, unit testing, all the army of bots that goes to work on your pull request once you actually send it out, software engineering is very much a process where the human programmer writes out a pull request, writes out a piece of code, and then you have linters, you have static analyzers, you have tests, and all this stuff that it's the machine that acts on it and then integrates it into the larger body of code that we have. And so you can think of this long march of progress in terms of how we develop software. Obviously, we started with binary machine code. Assembly code made that kind of irrelevant, right? You didn't need to program in zeros and ones. Compilers made assembly language unnecessary. And we've just gone on and on from then. We have really high-level languages that are super productive, operate at a very high level of abstraction. We have interpreters, we have virtual machines. Garbage collection makes it so that you don't have to explicitly think about memory management. And of course, on the tooling side, we have IDEs and IntelliSense and autocomplete. And the angst around those kinds of technologies has always been there. this was a very popular at the time article by Charles Petzold, who's a technical writer. He's written many programming books. And in this piece, he really laments how IntelliSense and autocomplete is destroying programming as he sees it, right? He thinks that this is, rotting his mind. It's making programming a less skilled activity. And the kind of code that IntelliSense and autocomplete enables is just bad code. That's the case he's trying to make in this piece. And there's a real primitivism here. The thing he's wishing for, just like he said, plain old C with no assistance, just in a plain text editor. It's just me and the code, and I feel like a real programmer again. And so there's this kind of nostalgic primitivist line of thinking. And this is the same as if you were nostalgic for your childhood. That world doesn't really exist. And that brings us to the present moment. Of course, we have, everybody's heard of ChatGPT and large language models. And everybody, like I was saying before, is kind of fancied by its conversational uses, where you just kind of shoot the breeze with ChatGPT. But I really think there's a much more concrete use case staring all of us in the face, and that is the impact of LLMs on programming. So, quick straw poll, how many of you program regularly? All right, so like 60, 70% of the room. And how many of you have used some kind of LLM, whether it's ChatGPT or Copilot, while doing that programming? So more than half of that initial set. So that's great. And I'm guessing that part of it was really exciting in terms of what it enables. Part of it was a bit disorienting. I'm hoping to cover some material which shows the promise of what this new set of tools will enable, but also highlight some of the, at least what I feel is a sense of disorientation and unpredictability. I feel as if we're at another step function, and I personally feel like a programmer that would have gone, say, from assembly language to compilers, they would have felt very disoriented, as if like the entire tool set and set of abstractions they grew up with were changing. So with LLMs, what do LLMs do? They are language models. They take natural language input, right? They are directed by plain English language. So it's almost as if that's the cool new language now. So Copilot is one of the most well-known ones. Obviously, that's not the only one. You can just ask ChatGPT for code. Copilot is special in the sense that it has all these integrations in Visual Studio Code and IDs and so on. I won't go too much into what it does. Hopefully the people that have used it already know. It will obviously let you write code off of comments. It will complete code. But it also does things like you select a bunch of code, you right-click and say, generate unit tests for this, and so on. And usually it's pretty good. So I'll get into some stats, but just from my own personal experience, it's really helped me write more code faster. That's the core value proposition. Interesting factoid, even for really obscure languages like Emacs Lisp, so I'm a long-time Emacs user, I write Emacs Lisp once in a while, and I didn't think it would be any good at Emacs Lisp because it's such a niche language, but it turned out to be pretty decent at Emacs Lisp, which really surprised me. All right, so the first thing I want to look at is, if you look at the pipeline of software engineers, I want to look at the beginning of that pipeline, the learning and teaching part of the pipeline, because I think there's a sea change coming to the way we teach programming and the way we teach computer science. The first question obviously is, well, how do these models, these LLMs, Copilot, how good are they at introductory programming? So if I was a student in a CS 101 Intro to Programming kind of course, would it help me? And the answer is yes, it would a lot. This is a paper that is even before GPT-4. This is from 2022, if I remember correctly. It took a bunch of intro to CS, kind of programming questions and fed them straight into Codex, which is one of the LLMs predating Copilot. And it saw how well it did. This graph on the left is its performance on 2 tests. So x-axis is one test, y-axis is another test. The circles are how the students did, and that little red star is how Codex did. So it's in the top quartile. It scored 17 it came 17th out of the 71 students in the class. The second graph on the right is just how well it scored on all the questions, or a subset of like 20-odd questions, and it gets a 1.0 if it's automated grading. So you submit your question and it runs it against a bunch of unit tests. So you get a 1.0 if it passes all the unit tests, or some fraction if you only pass a fraction. So as you can see, it did pretty well. And what they noticed was it gets even better, because on the parts where it failed, they then saw that you can get a passing reply by slightly tweaking the question. So once again, the input to this is just the English language question, and it's coming up with code that's putting it in the top quartile of an intro to CS course. So the answer to that question was, yes, these LLMs do really well at introductory programming. Well, the second question is then, well, what do you do with it? Like, what kind of experience do the students have? How do the teachers deal with it? And some of the same authors did a follow-on study to see how a novice set of programmers, so students in a CS 101 kind of class, how they use these LLMs throughout their course. And they came up with some really interesting findings. All right, they noticed 2 large categories of behaviors. The first one they call shepherding. And this includes things like changing the comment or the prompt or the suggested code from Copilot to get it to do what they wanted, right? So they're trying things out. They're not quite 100% accepting what the model is telling them. And so they call this set of behavior shepherding, where they know the kind of result they want to achieve, and they're trying to tweak the prompt, and they're trying to kind of push the model to achieve what they want. The second class of behavior they call drifting, and this is more exploratory, where the students aren't really sure of what end they're trying to achieve, but they're just kind of messing around with the model. They're trying a bunch of different prompts. They're changing the code. They're trying out different variations of the code of the suggestions that the model gave them. And they call this pattern drifting. So shepherding is a bit more goal-oriented. Drifting, much more exploratory. And they saw a whole bunch of behaviors, some of which were great, some of which were concerning. For novice programmers particularly, there are some cognitive issues, because when you don't know the programming language so well, you're just starting out, you're learning, you can't distinguish a good suggestion from a bad one, or a correct one from an incorrect one, or idiomatic code from non-idiomatic code. I like this comment over here. It's intrusive because it keeps filling up the screen with suggestions. So sometimes, as a student, you don't just want it to keep blurting out suggestions. On the plus side, they also saw a lot of really positive responses from the students. For people who feel that the barrier to learning programming is really high, this was a huge boon. They felt like they had a lot of assistance, a lot of help, and it made it easier for them to get into programming. So much faster. Many students felt that syntax errors, which some teachers will argue is probably the least important part of programming, and the thing that trips up students the most, the thing that frustrates them the most, it allows you to kind of go past that barrier and helps them have an easier time getting into programming. But here's the catch. LLMs are not perfect. They don't generate 100% correct code 100% of the time. They're pretty good. They have a pretty high hit rate, but they do not always generate correct code. And this is a really important point. Hold that thought in your mind. But especially for novice programmers, that's a problem. Because, again, they don't have the level of experience required to distinguish good answers from bad or correct answers from incorrect answers. Interesting thing, not related to like how they were using it, but just in terms of their feelings about the tool, almost all of them anthropomorphized the tool. They felt as if the tool had some kind of agency. It was a person. It knows what I'm trying to do. It read my mind. It's a very common way of people reacting to these tools. Now, from the point of view of teaching, obviously, teachers were really worried about what this means for academic integrity. If you have a tool like this, which just takes an English language description of your question and spits out the answer, how are they even supposed to grade? How are they even supposed to test that the students are learning what they're supposed to learn? And this, I think, is still an open question. I don't think anybody knows. If you were to go to a university and ask professors and teachers and lecturers what their strategy is for teaching in the age of Copilot, I'm not sure they have any clean answers yet. It's something we're all thinking through. Interestingly enough, all the plagiarism detectors seem to fare pretty poorly with code from LLMs. So that makes this an even thornier problem. And then you can go further down this chain of questioning. Those were novice programmers. Well, what about experienced programmers? How do experienced programmers use these kinds of tools? And you'll see kind of a shadow pattern. The two big patterns researchers found with more experienced programmers were what they call acceleration mode and exploration mode. Acceleration mode is where the programmer knows the end they want to achieve. They know what they want the code to do, and they're able to frame a prompt or a comment to get that and just get their work done faster. And then exploration mode is where they don't know the exact end they want to get to, but they're kind of messing around with the prompts, messing around with the models to see what their options are. So you can make the parallels, right? So shepherding and drifting are like the shadow versions of acceleration mode and exploration mode. So same kind of behaviors, except that when novices do it, it takes on a slightly different tinge. I found this really interesting. So these two studies I just talked about, they're talking about professional programmers. I'm not aware of any studies which try to see what the impact of this is on people that don't program for a living, but that do a lot of programming as part of their work, like scientists, people in research labs. You know, if you're doing life sciences, at some point you'll have to do some statistical analysis on your data. You might have to write a bunch of Python code in a Jupyter notebook somewhere. And by all anecdotal appearances, it looks like these LLMs are a huge boon for this set of people. So people who aren't professional programmers, but who do need to write code to do their job. Okay, so let's turn our interest a bit towards the legal side of things. So for students, for learning, this is all great. Programmers are using it. There are some open questions with respect to the legality of it. You will find that in most big tech companies, the use of these LLMs is just flat out banned. So if you're Google, Microsoft, Netflix, Facebook, you're not going to be able to use Copilot to write your corp code. And the reason for that is that the legality of code that is spit out by an LLM in terms of what license does this code have is still an open question. And big tech companies, the companies that actually write code for their main product, just don't want to take the risk. There are a few lawsuits happening already. The main claim in these lawsuits is that these LLMs are essentially license laundering code. So we'll have to see what kind of legal precedent is set, what the courts say. But that is one huge factor that is actually keeping these kinds of tools from being adopted inside large companies. Now, a lot of these big tech companies, especially like the Metas and Microsofts and Googles, they will actually have their custom in-house LLMs because their internal code bases are so huge that they can just train an LLM on their own code base and not have to worry about licensing issues. But if you're like a smaller, medium size software company, this is something you have to think about. Okay, so I want to cover a few things that give us a taste of, well, what happens after Copilot? So Copilot is, you write out a prompt, you get some code completions, great, but is that all there is to it? Where could this stuff be going? What's next? What are the cool things on the bleeding edge that people are trying out in academia? So I want to give you a bit of a taste for that, of papers that just got published in the last 12 months or so. So super fresh stuff. One of the approaches that I found really interesting was the system called Parcel, built by some researchers at Stanford. And what Parcel is trying to do is mimic the way human programmers will take a high-level problem, and break it down into smaller subproblems. So the way Copilot LLMs work right now is you give it a prompt, but the prompt is talking about a specific part of your code. It might be talking about a function, or it might be talking about a for loop. But what if you have a higher level problem you want to solve? And Parcel is a great demonstration of how you might want to approach that. So let's look at a quick example. The example here, I've taken it from their paper, is looking at how to compute the collapse numbers. It's defined by a rule. It's like a recursive rule like factorial. So this is like factorial on steroids essentially. And the input being provided is basically just function signatures, right? Function signatures with a little bit of English language description, and these red numbers over here are input-output examples. And then you have, again, function signatures and English language descriptions for some of the recursive things. And the Parcel system takes that and generates code. So it's doing a bit of a search through the space of possible code as produced by LLMs that also meets all these input-output examples, but it's doing all the heavy lifting. And so here's a typical cognitive loop that you might have when you're working with a system like this, where you have an English language description of a task, and that gets broken down into a sketch of a solution, which gets broken down into a set of function signatures with English language descriptions of what those function signatures are supposed to do, and you finally get a program out of it. Now, this is really interesting. The author, if you follow him on Twitter, he's been posting updates even since he published that paper, where he's been pushing this. He's been pushing how far you can get, how many details can you omit while still getting some kind of functional code at the other end. And so he had one update where he said, you don't need to write function names and args, right? Just write the English language description. And he's still getting functioning code out of that. And then a few days later, he had another update where you don't even need to write unit tests, right? You can kind of infer the input-output examples from the English language description. So yeah, Twitter is a great place to kind of follow the latest bleeding edge on this kind of stuff, because people will put stuff on Twitter that they haven't yet published. So even archive, it's surprising to see, is sometimes not quite up to date. One mental model that I found kind of interesting in thinking about how LLMs work with code is, it's not so much about prompting. It's almost like a compiler. So I feel like LLMs are like a new paradigm of compilation, where the input is English language, the output is code. Like Karpathy was saying, English is the hardest programming language. All right, so this is another really, really interesting pattern. Now, the problem with a lot of these LLM completion tools is that they have a hard time working with an existing code base. So imagine, you're working in a corporate code base, you already have like this huge code base, and you don't want generic completions, right? Like you don't want completions that are based on all the open source code in the world, or if you're writing Python, you don't really want like NumPy completions or Django or whatever. You want completions that talk about the classes you already have, the code that you already have. How do you do that? And this brings us to a really interesting kind of search and retrieval pattern that is often used with LLMs, where you combine the power of LLMs with traditional search. And what you try to do is, hence the name doc prompting. So you take the existing set of code or documentation that you have for your existing code base, and you index that, you create an embedding of that. So you put that in a vector database. Now, an embedding is basically a kind of database where you can look up distance relationships between words. And you can then give an initial prompt which you can search against your existing code base using this vector embedding. And the results you get back from that, you can stuff into your prompt and get back much more customized completions. So this is a way to use LLMs along with searching and indexing over your existing code base to give you completions that are relevant to your local code base. And this is really promising because this now enables you to use this for your existing code base, not just get generic completions. And Steve Yegi, popular blogger, now is the CTO at SourceGraph, he wrote a long blog post about how this works. I'd encourage you to go check it out. But same idea, you complement LLMs with retrieval to get more custom completions that are based on your corpus. Self-plug, I have a little video on my channel which explains this in a bit more detail if you go check out my YouTube channel. All right, so I want to go on a slight tangent because I feel like this is really interesting. Look at the name, right? We call it Copilot. And it's impossible not to make the comparison with the other kind of automation that we know of, which is flying, right? So flying has been automated now for a very long time, for decades. Almost all commercial flying, almost all of the time, is done on autopilot. There are very rare circumstances when pilots actually have to manually fly the plane. And I think there are some really interesting lessons we can take from that domain to help us frame our thinking about how these kinds of tools will affect the cognitive patterns of programming with these new tools. So this is a person called Captain Vanderburg, who I think back in the late 2000s was brought in to teach United pilots about how to approach automation after they'd had a spate of accidents or near accidents because of problems with autopilot in the cockpit. And one of the main points he's trying to make is that if you look at the levels of automation, the default assumption that most people have is that the highest level of automation, the thing that takes away the most cognitive load from you, is always the best. So right, full autopilot, full auto throttle is always the best. But what they learned by looking at the accident record was that there are plenty of situations where you will actually do much better, or in this case, avoid accidents if you don't default to the highest level of automation, if you come down a few levels of automation. And you can draw the parallel to programming because there's often times when in order to actually debug something, you have to break through a bunch of abstraction barriers, right? You maybe have to break through the source code for the library that you were using as a black box. Once in a blue moon, you might run into a compiler bug, right? The compiler which you took as the perfect piece of software sometimes has bugs, and you have to go look at the assembly output by a compiler and see if there's a bug in that. So main takeaway from that is you've got to think of the levels of automation. Even then, the end was good because of this, even though we've seen accidents related to pilots being confused by automation, flying as a whole has just become tremendously safer as a result of autopilot. So there's rewards, there's risks. I want to point out another classic paper. This is from back in 1983. This is one of the most cited papers in the cognition of automation in terms of how humans deal with automated jobs. And the reason it's called Ironies of Automation is because the author here really looks at, well, what is the mental state of a person who is now put into a position where a lot of their job is automated, but they still have to monitor the output. So bring this back to the idea of LLMs are not perfect. They will produce incorrect output. So just like autopilot on planes is not perfect. There are times when you need the pilot to take over and fly the plane manually. So what's left after something is automated, you still are left in this mode of monitoring things. And that, from a human cognition point of view, is not a great place to be. Because you're lulled into kind of assuming things are going well most of the time, but when things don't go well, you suddenly have to get into this mode where you need to have a very high level of skill and cognition. So there's been a long literature on this, is the point I'm trying to make, and there's some interesting cognitive problems and cognitive traps that we have to be wary of. I want to point out another talk also given at one of the ACM chapters. I think this was in Chicago by Matt Welch, who used to be a computer science professor at Harvard, but has been in industry for a number of years. And he gave a talk at the Chicago ACM chapter a few months ago about how he thinks programmers are just going to flat out be out of jobs in a few years, right? That all we will be left with are PMs, program managers, writing product requirement docs. So those are the English language inputs to your LLMs, and you'll have code coming out the other end. Which even to me, I'm a techno-optimist on the whole, seems a bit far-fetched. But then, look at the S-curve of various technologies, right? At the beginnings of an S-curve of technology adoption, claims like this seem far-fetched. But then by the time you're at the middle of the S-curve, the top of the S-curve, it's usually not so unrealistic. Yeah, so that's what he's saying. Programming will be obsolete. All right, so we've covered a lot of ground. We've looked at pedagogy. We've looked at law. We've looked at some of the cognition behind automated systems and how humans deal with it. What we as programmers, what should we be doing with all this stuff? My personal opinion is that this is a change as fundamental as the change from assembly language to compilers. It's that fundamental of a change in terms of the way we program and the tools we program with. And we just haven't felt the full impact of it yet. I feel somewhat unsettled by a lot of this because all this is still so new. The best practices are not yet known. We don't know what's on the other side of this technology evolution. But I think the best we can do is actually learn and use these tools, keep our eyes wide open, not turn away from these tools. The best way to stay relevant is to actually see what the limits of these tools are and to sharpen our skills to do even better with these tools. So I'll end with a thought. They say about, if pottery is an art, potters still have to love the feeling of clay. And I feel that we as programmers, we're in that place now where the clay we work with is changing. And that's both an exciting and a frightful time to be. So thank you very much for your attention.
So today, are there any particular tools that you're using in your day-to-day workflow? Maybe not necessarily for Google, but whether it's like I don't know, any tools besides Copilot, let's say Perplexity or what have you, that folks might want to check out?
That's a good question. Yeah, so like I said, obviously none of this is used for in-corp code in my day job. For my own personal projects, at home, yeah, I've been using Copilot. I've used some of the OpenAI models directly, like just through API calls when it's something a bit more conversational. But Copilot is nice because it just integrates with my editor, which is not Visual Studio Code. Yes. But yeah, I like Copilot a lot, and then sometimes for my own personal stuff, I'll use the GPT models, but through the API. I don't really like the website so much. I'll frame my conversations through the API.
Thank you for this presentation, really great. I have one question, like you mentioned that programming maybe can be automated through LLM. What about what's your take on software architecture, things like scalability, performance, reliability? Will there be a point when they will be automated? Just wanted to hear your thoughts.
Yeah, I think that's a great question. I think a lot of that is still currently the domain of humans, right? So if you look at what some of the people like Matt Welch are saying, they'll say, we'll have PMs writing specs, PRDs essentially, and a lot of what software engineers will be doing is not so much writing code, but reviewing code, right? So from writing code to kind of reviewing code that is produced by LLMs, and as they get even better and better, you maybe won't even need to review code. I think what you're asking about comes back to a question of scale. So if you're talking about, the Googles and Netflixes and Metas of the world, where architecture and performance and scalability is really important, and they work at a frontier where those things are highly customized and not off the shelf, well understood, then yes, you're still going to need humans. But if you look at the vast majority of kind of the bottom of the software pyramid, if you don't look at the tippy top of the software pyramid, but you look at the middle and the bottom of it, which is like medium businesses, small businesses, they're not dealing with problems that are that technically challenging, right? They don't need a super performant backend that scales out to a data center. So a lot of that, I think, is perfectly automatable even today.
How much of LLM has got into Alexas and Siris of the world?
Alexas and Siris, that's a good question. I don't know. What are you looking for? Like, what's the application you were hoping for?
It's the conversation piece of it. Because that's what most folks are
right.
And they get frustrated because it's not really answering or understanding what they're saying.
Yeah, I think that's a great question. There's definitely a lot of scope for using LLMs in that kind of a conversational setting. It's basically the voice equivalent of what you do with ChatGPT where you're typing. So I don't really know what the internal implementations of these things are like, but sounds like a reasonable place to do it. I do know that a lot of the challenges in these voice assistants are not so much in the knowledge retrieval part of it, but in the engineering of the voice recognition. So I think they could do it, but that's not where the big problem for them lies.
You just mentioned that you are using API to talk to the model there. So that means you have to send a whole your code base to the model there, right? Are you doing that?
No, I'm not doing that. Usually I will just frame my prompts as, English language descriptions. There are times when it depends on how big your program is. So a lot of these context windows now are getting larger and larger. ChatGPT started out with, so the context window is how long your prompt can be. It started out with a context window of, if I remember correctly, like 2 kilobytes or something. GPT-4 goes up to 8 kilobytes, and there's a version with 32 kilobytes. Some of the more recent LLMs go into the megabytes. So if you have a small code base, there's plenty of open source projects where the entire code base is a few megabytes. If you have a small enough code base, you could actually stuff your entire code base into the prompt and then ask questions of it. But actually the better way of doing it is to index your code base into a vector database and then use your initial prompt to retrieve matches out of that vector database. I'm not doing any of that fancy stuff for my personal programming. But if you were to do it on a large code base, that's how you would do it.
Very interesting talk, Vivek. You touched upon a lot of topics. There are a lot of naysayers as well on AI. And I know you are not a sociologist, but because you are a well-read person, I want to ask you, what are the social implications of all this? And I think you touched a little bit about some jobs going away, but I would like you to comment further on that.
Yeah, that's a great question. I think there is a lot of FUD around a lot of this, fear, uncertainty, doubt. So the big question everyone asks is, well, is this going to destroy jobs, make humans obsolete? And if history is any guide, I don't think so. There have been wave after wave of automation and technology throughout history, and it's certainly been painful in the moment, right? The Industrial Revolution and then PCs, the internet. But on the whole, humans found better things to do. I found someone made a funny tweet the other day, which is, before they had spreadsheets, Wall Street analysts had to work long nights and weekends. And after they had spreadsheets, they didn't have to do any of that, which obviously they didn't, right? So I think there's still lots for humans to do. There is a difference, though. Some of the AI doomers will say that this is the final level, this is the boss level of human cognition, right? All the previous levels of automation, they took away certain parts of what humans do, but like philosophers say, like the soul of what humans do is think, right? I think, therefore I am. And this is different. This time it's different. This time they can think, right? So I don't know. I don't have a clean answer. I myself am kind of a techno-optimist. I think a lot of the claims of the AI doomers are much too hyped and much too speculative. So I personally still think there's always going to be a role for humans.
Thank you for the presentation. You discussed, as the previous person mentioned, different subject matters. One of those was the operators in industrial plants. And one method that is used is to use simulators to train the operators, because the environment they are in, it's typically boring for hours.
Right.
An interspace with sheer terror on a short-term notice because of the upset or what's called abnormal situation. And there is a whole body of literature, abnormal situation management. And my question has to do with the application, to how far the analogy is holding and is applicable from industrial controls or from piloting of an aeroplane, because pretty much the human intervention is in an abnormal situation.
Yes, yes.
And that's what the pilots are getting trained. And now question is this applicable? Is there a certain extent where it analogy breaks down, or are the lessons applicable and can be brought over into the programming and software engineering?
Yeah, I think that is a great question. I think that gets to the heart of the cognitive shift that we as humans have to face. Not just with this set of tools, but anytime there's like any kind of automation. You're right. One of the main problems, and that's what Bainbridge is calling out in this classic paper, is this monitoring effect, right? Where you get lulled when things are working well most of the time, and then something breaks, and suddenly you have to kind of get back to a very high level of cognition mode. And that's usually very surprising, and that almost always leads to some kind of accident or some kind of disaster in kind of an industrial setting or an aviation setting. I think you can carry that analogy pretty far, because if you look at debugging, the act of debugging is essentially the analogy of an accident in the industrial or aviation setting, where things are not working as expected, and suddenly you now have to show some understanding of what's happening behind an abstraction. So when an abstraction breaks down, an abstraction is leaky, it doesn't perform as you expected, you need a higher level of expertise. The saving grace, I think, in the software scenario is that it doesn't have to be the same person, right? You can call someone else that is more experienced or more knowledgeable. And I think there's always going to be a need for this. So even if you look at LLMs right now, they're really good at kind of enterprise software, machine learning, all the stuff you do with Python and pandas and whatnot. But you still need people to write things like the Linux kernel or the Java virtual machine or the C compiler. And I think it's less useful at those lower levels of abstraction. It might get better. You never know. But I think that is a great analogy. So for when things do break down, when you have to debug something, when there's an outage, you need someone that has a higher level of understanding and knowledge to jump in. And I think that's one of the fears of teachers as well. So if you look back to like the pedagogical implications, what teachers are worried about is, well, it's generating code, but the students don't yet understand it, right? If you don't know what you're doing, it can confuse you even more, right? This is a quote from a student. It gives you code that you do not know what it does. I think that's the risk, that you still need a way for students and others, practitioners, to have an understanding of what's going on.
Yeah, I know a lot of the training, it seems like it's done with public data, like on Stack Overflow, where human asks questions and then you have answers in code. But now people are getting answers directly in code. They're getting just what they want. They don't ask those questions anymore. So is that going to reduce the training data down to a point where you're not getting new knowledge that's happening in the programming space?
Yeah, that's a great question. And not just for that scenario, I worry a lot about that effect when it comes to new languages and libraries. So with Python is great. The corpus on which things like GPT and Copilot were trained is full of Python, full of machine learning code. And Python is one of the languages it works best on, along with like TypeScript and JavaScript, the common languages. But imagine you're trying to get traction on a whole new language that doesn't have a good corpus. So I think that is going to be a barrier for new libraries, new languages. Because if I'm trying to get traction on a new language, one of the things I'm going to have to build is tooling so that new programmers can get good autocomplete for my new language, which all these models don't know about yet. So yes, you raise a good question, and that's the question of they've been trained on the state of the world up to now, and what happens after this. Like, do you just keep updating your LLMs, right? You just keep, like you update a search index, right? Google is constantly crawling the web and constantly updating its index. Do you keep doing that with LLMs? I think you're going to eventually have to do that. There's some technical hurdles to that, in that training up LLMs is computationally very expensive. It's not as optimized and as cheap as updating a search index. But yeah, they've got to figure it out to make it so that the models stay up to date with the state of the world.
To kind of tie that all back together, I'm curious how these tools have changed the way that you write code on a daily basis. Because I mentioned Perplexity in my initial question, because on the topic of using vector search and embeddings, Perplexity is one of these search engines that has a conversational interface similar to Bing. But something that I've noticed myself doing a lot is, to your point about there being a large corpus of text when it comes to Python. The same thing I think is true when it comes to debugging certain software problems. So like you're working in React or Django or whatever it is, and you come across some bug, and there's probably a bunch of people that have come across the same thing, right? And so I find myself constantly asking, hey, I have like this particular part of my stack trace, sending that to the LLM, and it can use the internet as its index,
right,
find all of the relevant conversations across Reddit and all these forums, and give me back the answer that would have taken me. I would have been able to do it myself, but like it's saving me a bunch of time, and that's one of the ways that my work has changed as a programmer. So I'm just curious how these things have maybe affected your own work, and just I'm curious how this is changing the way that you are doing what the work of software engineering in general.
Right. So great question. I'll take that in two parts. So in my day job, well, I'm mostly an engineering manager in my day job, so there's less coding there. But from what I've seen with most programmers inside like Google, and I think big tech in general, right now they are a bit shielded from this. So obviously we can't use Copilot or any of these models for actual production code inside a corp setting. We can't do that. So we don't have a good kind of set of experience for how that would work. Now, I've definitely used it for my personal projects at home, and it's been awesome in the sense that it's brought down the barrier for what I can get done in a weekend. So if I have a personal programming project, I've got to get it, some fraction of it, some important subset of it done in a weekend. And there were problems which in the past wouldn't fit in a weekend, I just wouldn't do them, right? They'd never get done. And now the barrier is reduced enough that they do get done. So that for me personally has been amazing. I've loved it. And I think it's similar for a lot of other people. Like they find that they can get stuff done faster. The only caveat to that is, again, I think the way in which novices use it versus the way in which experienced programmers use it is very different. So I would have probably written the same code, but it would have taken me a bit more reading the docs or a bit more Googling around, and it would have taken me 30 minutes instead of 5 minutes or something. But I knew enough about what I wanted. I knew enough about the language I was using that I could tell if what the model was telling me was good code or not. So on the whole, it's been good. I've personally loved it. It's been a boon to my little personal side projects.